Now that we've talked about absolute value equations, let's look at absolute value inequalities. And we're going to need to consider two separate cases. We'll start with the less than or or equal to case. Let's consider the inequality absolute value of x is less than 3. So I want to find what kind of numbers might satisfy this inequality. Well, we know that numbers less than 3 like 0, 1, and 2 will work. We also have some negative numbers like -1 and -2 will work. However, smaller negative numbers aren't going to work. The absolute value of -4 would be 4, which is not less than 3. So we do have a cutoff for how low we can go. And this list right here is absolutely not all of the solutions. We also have 1.5 and 2.789, etc. But it does give us a general idea and a place to start, which says that the absolute value of u is less than a is equivalent to the inequality -a is less than u is less than a, where once again u is an algebraic expression and a needs to be a positive number. So for the example that I started with, I have -3 is less than x is less than 3. We know this is equivalent to the interval -3 to 3. If we want to graph this, we're going to use open dots on both -3 and 3, and we'll shade in the middle. So now let's look at a more complicated example. This time I have the absolute value of 3x plus 7 is less than or equal to 16. Since this is a less than case, I can use the method that we just talked about. And that gives me that -16 is less than or equal to 3x plus 7 is less than or equal to 16. We then subtract 7 from all three sides. And we get -23 is less than or equal to 3x is less than or equal to 9. We then divide all three sides by 3. And we get -23 over 3 is less than or equal to x is less than or equal to 3. We can represent this in interval notation with -23 over 3, 3 in square brackets since we're including these points. And I can graph it. Here's my number line. I'm going to use closed dots since I include these points. And then shade in the middle. Now that we've dealt with the less than case or the less than or equal to case, let's consider the greater than case. The absolute value of x is greater than 3. So once again, let's try to think of some numbers that have an absolute value of x bigger than 3. Well, we know the numbers 4, 5, 6, 7, etc. are going to have an absolute value bigger than 3. And since sign doesn't matter with absolute value, we also have -4, -5, -6, -7, etc. So we can be both bigger than 3 or smaller than -3. So when we're looking at these, the absolute value of u is greater than a is equivalent to u is greater than a or u is less than -a. In our basic example here, we would have x is greater than 3 or x is less than -3. In interval notation, we would have 3 to infinity with parentheses, or -infinity to -3 with parentheses. And as a reminder, we use this symbol for union, looks like a U, to indicate that you have to be one or the other. Here I have a number line. I want to consider all the numbers bigger than 3, so I use an open dot on 3 and shade to the right. I also want to consider all the numbers less than -3, so I use an open dot on -3 and I shade to the left. So this is what these look like. Now let's look at a more complicated example. I have the absolute value of 2x minus 3 is greater than 13. Since this is a greater than case, we're going to have the two separate inequalities. 2x plus 3 is greater than 13, or 2x minus 3 is less than -13. We start on the left by adding 3 to both sides. That leaves me with 2x is greater than 16. I can then divide both sides by 2, which gives me that x is greater than 8. Now let's look at the second equation. We start by adding 3 to both sides, which gives us 2x is less than negative 10. Dividing both sides by 2 gives me that x is less than negative 5. Now let's try to write this in interval notation. X is greater than 8 tells me I want numbers bigger than 8, so 8 to infinity. And x less than negative 5 means I need smaller numbers, so negative infinity to negative 5. And once again, when we want to combine two of them with the or, we put this symbol for a union that looks like a U. So that just tells us it needs to be in one or the other. I now want to graph. My first interval says I need an open dot at 8, and I need numbers bigger than 8, so I'm going to shade to the right. The second one says x is less than negative 5, so I need an open dot at negative 5, and to shade to the left, the number smaller than negative 5.